Hey there, and welcome. Today we're diving into something that's literally everywhere, doing everything. It makes cars go, it makes your lunch grow, it makes music happen, but you can't see it. We're talking about energy, the invisible force that powers, well, everything.
So to get us rolling, let me ask you a question. What could a loud, blasting rock concert, the sandwich you ate for lunch, and the actual sun possibly have in common? I mean, they seem totally different, right? But believe it or not, they are all connected by one single, powerful thing.
You guessed it, it's energy. Think about it. The sun uses nuclear energy to create light. The plant for your sandwich bread used that light as chemical energy, and a musician uses that chemical energy from their food to make the sound energy blasting from their guitar. And for the next few minutes, we're going to go backstage at that rock concert to see all the different forms of energy in action.
So what exactly is energy? You know, in science, the definition is actually super simple. Energy is just the ability to do work. But that probably just leads you to another question, right? What in the world does work mean?
Okay, so work is just what happens when a force, like a push or a pull, actually makes something move. So when a drummer smacks a cymbal with a drumstick, they're doing work. When a roadie lifts a heavy speaker onto the stage, they're doing work. And to do any of that work, you gotta have energy.
Now, here's the cool part. Energy isn't just one single thing. It shows up in a bunch of different forms. You can think of them like different members of a band, each one playing a totally unique part. Scientists have sorted them into 7 main types, and we're about to find every single one on our concert stage. First up, you've got the real star of the show, mechanical energy. This is the energy of motion, plain and simple. Anytime you see something moving, a person running, a car driving, a drumstick crashing down, that is mechanical energy. At the concert, it's in the guitarist's fingers flying across the strings and the drummer's arms bringing the beat. It's the energy we can actually see.
But wait, where do the musicians get the energy to move like that? Well, that comes from chemical energy. This is energy that's been stored up, just waiting to be used. It's like a tiny coiled spring tucked away inside molecules. It's in the food they ate for dinner, which their bodies then uncoil for fuel. It's also the energy locked inside batteries, just waiting for you to flip a switch.
And what about all those huge stage lights and the giant speakers? That's all thanks to electrical energy. This is the energy of these tiny, tiny moving particles called electrons, usually zipping through wires. When that electric current hits the lights and speakers, it transforms into light and sound, and boom, the whole stage comes to life.
Okay, so that was the first half of our energy band. Now let's meet the other members, the ones that are a little sneakier, a little harder to see. These are the ones that travel in invisible waves or are locked deep inside atoms themselves.
As soon as those stage lights flick on, they're blasting the whole place with radiant energy. This is energy that travels through space in waves, kind of like ripples in a pond. We can see some of these waves and we call it light. But get this, most of these waves are totally invisible, like the radio waves that broadcast the concert to your car or the microwaves that heat up your popcorn.
And if you've ever been near a big stage light, you know it gets hot. That heat is thermal energy, which is really just the energy of atoms moving or vibrating. The faster the atoms wiggle, the more thermal energy there is, and the hotter it feels. And here's something that might blow your mind. Even a freezing cold ice cube has thermal energy because its atoms never, ever stop moving completely.
And of course, you can't have a concert without sound energy. Sound is all about vibrations. When a guitar string vibrates, it pushes the air molecules next to it. Those molecules then push the ones next to them, and so on, creating a chain reaction, a wave of energy that travels right into your ear. It's amazing, really. That vibration becomes the music you hear.
Last but not least, we have the heavyweight champion, nuclear energy. This is the mind-boggling amount of energy stored in the nucleus, the very center of an atom. You can release it in 2 ways. There's fission, which is splitting atoms apart. That's what nuclear power plants do. And then there's fusion, which is smashing atoms together. That's how our own sun makes all of its incredible energy.
Whew, okay. Mechanical, chemical, electrical, radiant, thermal, sound, and nuclear. I know, that is a lot to keep straight. But here's the good news. There's a much simpler way to think about all this. Every single one of those 7 forms can be sorted into one of just 2 main categories.
And those 2 types are potential energy and kinetic energy. It's actually pretty simple. Potential energy is stored energy. It's energy that has the potential to do something. Think about a stretched rubber band. Kinetic energy, on the other hand, is the energy of motion. It's energy that's doing something right now. like that rubber band flying through the air after you let it go. Stored versus moving.
So let's sort our list. In the potential, or stored, energy camp, you've got chemical energy in a battery and nuclear energy locked in an atom. Even a type of mechanical energy can be potential. Imagine that drummer holding a drumstick way up high. Because of gravity, that stick has the potential to fall and make a sound. We call that gravitational potential energy.
And on the other side, you've got kinetic energy, the energy of action. This includes radiant energy with its moving waves, thermal energy with its jiggling atoms, sound energy with its traveling vibrations, and electrical energy with its flowing electrons. Basically, if it's moving, it's kinetic. Simple as that. Okay, so now we have a pretty good map of all the different kinds of energy. But that brings up a really big question. Whether we're talking about the chemical energy in our food or the electrical energy lighting our homes, where does all this stuff come from in the first place?
Well, the answer is a staggering 93 million miles away. Nearly all the energy that drives life, weather, and pretty much everything on our planet comes from our amazing star, the Sun. Just think about this incredible journey for a second. The Sun blasts out radiant energy across the solar system. Plants here on Earth soak it up, and through this amazing process called photosynthesis, they turn it into stored chemical energy. Then we eat those plants, or we eat animals that ate the plants, and our bodies turn that chemical energy back into the mechanical and thermal energy we need to live. Yeah, almost every bite of food you take is basically bottled sunshine. And it's not just our food. The sun's energy heats up our planet, and as the source material puts it, this heating is what drives the winds, ocean currents, and the water cycle. The sun is the giant engine that makes our whole planet run. And all of this leads to maybe the most important rule in the entire universe when it comes to energy. It can't be created, and it can't be destroyed. It just changes form. That's it. Every bit of energy you see, from the light of the sun to the sound from a speaker, has always been here and will always be here, just transforming from one type to another in this constant, incredible cosmic dance. So, I'm going to leave you with a little challenge. Just for a second, look around whatever room you're in right now. The light from your screen? That's radiant energy. The warmth of your own body? Thermal energy. The sound of my voice? That's sound energy. Now that you know what you're looking for, how many different forms of energy can you spot happening all around you right this second?